And we're back. So the next part of our lesson is going to be all about looking at patterns between standard form and the slope of a line. So we discovered in the last lesson that the slope of the line looked something like the coefficient of x over the coefficient of y. So remember that standard form is always written in the form of ax plus by equals c. So our coefficient of x is that a value, and of y is that b value. So it's not simply that we just put x over y, but the slope, or the coefficient of x over y, I should say, a over b. But what we find out the slope of this line is negative 2 over 3. The slope of this line, and this is kind of an interesting one because what is the coefficient of x? Think about that. The slope of this line is negative 1 over 2. The next one is also an interesting one. Look at the coefficient of x and the coefficient of y, our b value. The slope of this line is positive 1. And finally, the slope of this line is positive 5. So let's take a look at what's actually happening. We're not simply putting a over b because we see here that there's a negative sign here. So we end up with 2 over 3, but with a negative here. We don't simply put 1 over 2, we have the negative here. We don't simply put 1 over negative 1, this here is a positive 1. And we don't simply put negative 5 over 1 because we're left with a positive 5. So here's the deal. The slope of a line in standard form is always, and this should be in your notes, the opposite of the a value over the b value. Think about this. If I simply put a over b, in the first example, I would have 2/3. It's not 2/3, it's the opposite of 2 over 3. In the second example, if I simply put a over b, the slope would be 1/2. Now it's the opposite. In the third example, I would have a 1 over a negative 1. It's going to be the opposite of 1 over negative 1, and that's where we get our slope of 1. In the fourth example, when I simply put a over b, it would be negative 5 over 1. We know that the slope should be the opposite of negative 5 over 1. Well, the opposite of negative 5 is positive 5. So slope is always found by looking at the opposite of the a value, that's this guy, coefficient of x, over the b value. And that's going to be very valuable for you once we start looking at horizontal and vertical lines, which is really the purpose of this part of the video today. Here we go. Let's say that I have an equation that looks like 0x plus 2y equals 4. If I go along with what we just learned, where the slope is the opposite of a over b, the slope of this line would be a negative, or opposite, of 0 over 2. Think about what we know about when 0 is in the numerator. 0 divided by 2 equals 0. This is a horizontal line. We know that because we know that the slope of a horizontal line is 0. So what we're going to look at next is, what is this equation, this 0x plus 2y equals 4, what does that look like when we simplify it? Well, the 0 times x, these cancel each other out completely. 0 times anything is always 0. So here's what I've got. 2y equals 4, which leaves me with y equals 2. You're going to notice that the equation of any horizontal line is always going to have that x gone, disappeared from it, and always simply going to be a y equals some number. Let's do a couple more of these. Well, we'll do one more of these and then we'll go on to vertical. So our slope here, we know the slope would be the opposite of A over B. That would be a negative 0 over 3. I see once again, notice where my 0 was. It's in the numerator, which means I'm doing 0 divided by 3, which equals 0. I have a 0 slope. We know that lines with a 0 slope are horizontal. And now we're going to simplify this equation. It's going to look very similar to the last. 0 times x, 0x, plus 3y equals 9. I know 0x cancels out. I'm left with 3y equals 9, which means that y equals 3. Again, a horizontal line. Notice, no x. The x is gone. We're left with y equals some number. And we'll get to what we do with that number on a graph shortly. The next part of our equation, we're going to be looking at something where the 0 value now ends up in the denominator. This should be familiar to you. The slope of this line, the opposite of A over B. Here's my A, here's my B. When I put the opposite of A over B, I see there's a 0 in the denominator. Remember when we divided 3 by 0, negative 3 by 0? On your calculator, this is going to say error. And we know what this means. We know this means, and here's that word that I said we need to commit to memory, this is undefined. What kind of a line has a slope that is undefined? You know this. It is a vertical line. Vertical lines have a slope that is undefined. So now let's look at what the equation of a vertical line looks like. So I'm going to go back to this. 3x plus 0y equals 6. The 0y cancels out. 3x equals 6. There's no y left in my equation. And I'm left with x equals 2. Notice what's different. Undefined slope, vertical line. Here's the equation of a vertical line. It starts with x equals. It's the only equation that's going to have a starting point of x equals. All of our other equations look like y equals. So that's something to help you keep in mind, that there's something kind of strange about these vertical line equations. All right, let's do the opposite of A over B. So I've got the opposite of 1 over 0. We know what this means. 0 in the denominator, error. This tells us that the slope of the line is undefined. And we know that only vertical lines have a slope that is undefined. So what do we think the equation is going to look like? Think about what I said. Is it going to start with a y equals or an x equals? So if I go back to this x minus 0y equals 2. 0 times y, we know what happens there. Goodbye. And look how easy. We're left with x equals 2. Undefined slope, vertical line, equation looks like x equals. And now we're going to talk about what these y equals and x equals equations will look like when we put them on the graph. So we're into graphing horizontal and vertical lines, like we've been talking about all along. We're looking at standard form, ax plus by equals c. We know that if that coefficient of x is 0, that a is 0, we know that the line is going to be either horizontal or vertical. If the b is 0, we know the line is going to be horizontal or vertical. So for horizontal lines, we know that a is going to be 0 because we're trying to disappear the x. There will be no x in the equation. And for a vertical line, we know that b is going to be 0. There will be no y in the equation anymore. All right, let's take a look over here. We know that a horizontal line is going to start with a y equals. If y equals negative 3, in standard form, what this means is that the a value, there it is, the a value has to be 0. This line is just for show. You're never going to have to use this kind of a line. What you're going to have to do is understand that for the equation y equals -3, and there it is again, all values of x, no matter what they are, 0, 1, 2, 3, 4, -5, -10, y will always be 3. So here's how we do this. If y is -3, look at what point I have on the graph. The y-intercept is at 0, -3. I plot that point. I don't need any other points on my graph. My brain just goes, oh yeah, I know that this is a horizontal line. I'm just going to make a horizontal line going across. So we plot our y-intercept and we make a horizontal line, okay? So the key to look for is y equals, notice there's no x in the equation, all right? For a vertical line, you already know this. A vertical line is going to start with this x equals. This line here, once again, is just kind of for show. You're never going to need this. But what you can see here is, look, the b value is 0, just like we said way up there, okay? When b is 0, we know the line is going to be vertical. But that's not what you need to focus on. You will always see an equation that looks like either a y equals some number or an x equals some number. What this is saying is no matter what y is, y could be 0, y could be 5, y could be -5. For any value of y, x is always 2. So watch this. Where do I plot that point? We learned this. That's the x-intercept. I can see that the x-intercept is over here at 2, 2, 0. So I plot that x-intercept. My brain goes, this is a vertical line, and I just know automatically to make my vertical line from here. Notice I don't have any other points on the graph. I plot my intercept, my x-intercept here, my y-intercept here, because it tells me y equals. This tells me x equals, so my brain goes x equals, then that's my x-intercept. And my brain goes y equals, oh, that's my y-intercept. Plot the point, make the rest of the graph. All right, now we're going to practice this. So if I have an equation, watch how easy this is, of y equals 5, my brain thinks y-intercept. I know automatically I'm going to make a y-intercept at 0, 5. That's 0, 1, 2, 3, 4, 5. My brain knows this is a horizontal line. I'm going to make a horizontal line. That's it. No other points. Knowing the y-intercept is enough. Look how quick and easy that was to graph the point. Let's take a look at the next one. Y equals -1. I'm going to plot. This is telling me y equals, so I'm going to plot on the y-intercept a point down at 0, -1. I don't need any other points because I know for every x value, y is always going to be -1. Ta-da! There's my point. Okay? So part of tonight's homework is going to be you graphing horizontal lines. And now, here, let's try some vertical lines. Same deal here, you guys. The x here is telling me, oh, that's the x-intercept. If x equals 5, I'm going to plot a point at 5, 0 on the x-intercept. My brain knows there must be an undefined slope here because b is 0. My brain doesn't even really need to know that. It only needs to know that when I see x equals, that is going to be a vertical line. Notice I didn't put any points on here because I know every y value is going to have an x value of 5. And for x equals -1, I'm going to plot on the x-axis a point at -1, 0. And again, there's my vertical line. Okay? Really simple. So a couple of problems on tonight's homework where you'll be doing horizontal lines and then vertical lines. And now the last part of tonight's homework. If you see a graph, can you write the equation? So you should be thinking, what does a vertical line look like? What does a horizontal line look like? When does it start with x equals? When does it start with y equals? In the first example, I see one point, and it's at the x-intercept, which tells me this is going to be an x equals. Well, what does x equal? Let's count from the origin, 1, 2 spaces, x equals 2. I see on this line the y-intercept. I know my equation is going to be y equals. Well, what does y equal? Y equals 2 because it's at 0, 2 on the y-intercept. Last one, horizontal line. Y equals -2. That is it. Graphing horizontal and vertical lines. All right, guys, you may start the homework. See ya.